have you ever actually stopped to think about how this video is getting to you right now? I mean, where is it really coming from? Let's dive into that, because the answer is, well, it's way more incredible than you probably think.
See, when you click play, it's not magic. Your request doesn't just poof into the air and reappear with the video. It actually kicks off this insane high-speed journey across a massive physical system that wraps around the entire planet.
And spoiler alert, it's not coming from the cloud. I know, we all use that term, but it's pretty misleading. The internet isn't some ghost in the machine floating above our heads. It's real, like, you can touch it real.
That's right. At the end of the day, the cloud is just a catchy marketing term for a giant, global network of physical computers, data centers, and massive cables. It's all hardware and software, tubes and wires. And that's the key takeaway here. To really get how the internet works, you have to remember that it's a physical thing.
So first up, Section 1, the internet is physical. We're going to look at the actual tubes, wires, and hardware that make this whole thing possible.
Then, in Section 2, the first and last mile. This is where our data's journey really begins, with you and that first step out into the global network.
Okay, so the moment you clicked play, your request had to get ready for its trip. First, all the data for this video got chopped up into these little manageable chunks. Then, to actually travel through the real world, those digital chunks were converted into physical signals. Radio waves if you're on Wi-Fi, or little pulses of light for a fiber optic cable.
And these little chunks, they're called packets. A great way to think about them is like this. Imagine trying to mail a huge book. You wouldn't send it all at once, right? You'd send it page by page in separate envelopes. That's what packets are. And just like a real envelope, each packet gets a label with a destination address on it, so it knows exactly where it's going.
All right, now for Section 3, the network of networks. Once those packets leave your house, they hit the superhighway.
Your local internet service provider, your ISP, sends your packets to a very real physical place called an internet exchange, or an IX. You can think of these as giant internet hotels, actual buildings where hundreds of different networks literally plug into each other to swap traffic. This is the glue that holds the entire World Wide Web together.
But how do they decide who sends what? Well, it all comes down to business deals. You've got peering, which is where two big, similar-sized companies agree to carry each other's data for free. Then you've got transit, where a smaller ISP has to pay a bigger one to use its network. These deals basically create the roadmap that our data follows.
And all of this creates a pretty clear hierarchy. Way up at the top, you have these massive Tier 1 networks that own the global infrastructure. Think of them as the giant interstates. Below them are Tier 2 networks that cover big regions. And then finally, Tier 3 networks, that's your local provider, who handle that last mile to get the signal right to your front door.
So how does a packet get from an internet hotel in New York to, I don't know, a phone in Tokyo? It travels along the internet's global backbone. And this is where it gets really mind-blowing. We're talking about an incredible network of undersea fiber optic cables.
Get this, there are over 400 of these active submarine cables crisscrossing the ocean floor. They are literally the physical arteries that connect our continents online. It's wild.
And speaking of these cables, it brings us to a really popular and kind of funny myth. A few years back, a video went viral of a shark chomping on one of these cables, and suddenly everyone was convinced that sharks were the biggest threat to our internet.
But it turns out that's not really the problem. The Internet Cable Protection Committee actually had to come out and say, sharks are not the nemesis of the internet. The vast majority of cable breaks are actually caused by us, by human activity. Mostly things like fishing boats and ship anchors dragging along the bottom of the ocean.
Now, for trillions of these packets to make this incredibly complex journey every single second, they all need to follow a universal set of rules. This brings us to Section 5, the rules of the road, the protocols that give the internet its structure.
The whole architecture of the internet is often described as an hourglass, and it's a perfect analogy. At the top, you have tons of different applications. Down at the bottom, you have all sorts of physical technologies. And holding it all together right in the middle is one simple universal protocol.
At the wide top of the hourglass, you've got all the stuff we actually interact with every day. Websites, email, video streaming, online games, you name it. This layer is built for endless innovation. Literally anyone can build something new up here. But the absolute magic, the real genius of the internet, is right here, in the narrow middle. It's the Internet Protocol, or IP. It's the one simple language that every single device and network agrees to speak. All it does is specify how to put an address on a packet and send it on its way.
That simplicity is what lets the entire internet connect to everything else. And then at the wide bottom, you have all the different physical technologies that can carry the data. The beauty of this system is that it doesn't care what the technology is: fiber, Wi-Fi, cell signal, even old-school copper wires. As long as it can carry a packet that speaks IP, it's part of the internet.
To make it even clearer, let's look at the two star players. You've got IP, the Internet Protocol. That's like the street address on the envelope. It just tells the packet its final destination. But what happens if some packets get lost or they show up in the wrong order? That's where TCP comes in. It's like a delivery checklist, making sure every single packet arrives safely and then putting them all back together in the right sequence. They work together to make a messy, chaotic internet feel totally seamless and reliable to us.
So after traveling across cities and under oceans, all those packets carrying this video have finally been reassembled on your screen. But this whole physical system, it's not owned by any one person or government. It's this interconnected web of private companies, which, as you can imagine, raises some really big questions about who's in control.
And this brings us right to the idea of net neutrality. It's the principle that the companies who own the pipes of the internet, those ISPs, should have to treat all data the same. They shouldn't be allowed to slow down content from a competitor or create special fast lanes for services that pay them more. It's really a debate about whether the internet should be treated like a public utility, guaranteeing a level playing field for everyone. And that really brings us to the big takeaway. The internet isn't a finished product. It's a massive, physical, human-built system that we're all still building, every single day. And that leaves us with a pretty critical question to think about. As we build the next version of this global network, who gets to decide what the rules are?